Hello there, welcome back to another video. And guys, as I said in the last video that we will change our formulas so that we can use gradient base gradient descent. So in this video I'm gonna update all the formulas that we have discussed so far. So let's take a look at the formulas that we have. Basically we have dl by dw, and for this what we had is al minus 1 and delta L. Okay, so we have this, and what we did is basically this is for the last layer. Okay, we can also consider the uh, delta L, this part. Basically we what we are doing here is we are finding the gradient on the basis we are finding the different derivative of this loss on the basis of the bias. So for this it is just going to be this. Okay, so we are not gonna discuss about this. So let's take a look at our neural network. So let's suppose we have something like this. We have two neurons in the output layer, we have two neurons in the input layer. So this is input layer, this is hidden layer, and this is output layer. And let's suppose we have 500 examples. Okay, so our x is our 500 examples. So the shape of this is going to be 500 times 2. Okay, now our y, for our y, what we have is we have two values here. So for this what we are going to do, we will have again 500 values times 2. Why it is 500? Because we have 500 examples, and why it is 2? Because we have two outputs. Okay, so this is going to be our shape for x and y. So for this part, delta L, it is nothing but y hat minus y. This is the original y that we have, which is this, and this is our predicted values. So this is also they both are going to be of the same shape. So let's just consider that this is also 500 by 2. Okay, so now what we have is this is basically 500 by 2, the output the shape of this is. And now what we have to do is we have to take the activation value from the previous layers. Okay, now we have to check what is the shape of this. So the shape of this is basically we have three neurons here, so we will have three activation values, a a a. Okay, and as we have three neurons, so we will have three activation values, and we have 500 what do we say, we have 500 examples. So the output is going to be 500 times 3. So now what should be the shape of this? As I said earlier, that the shape of this should be same as so this is w, and its shape is 3 times 2. And now we are finding the derivative with respect to w. So to update this w, we need the shape of this as like 3 by 2. So its shape should also be 3 times 2. So now if we will multiply it directly, then we cannot multiply it like this. So what we will, so in this case what we can do is we can take a transpose of this. So this can be 3 by 500 into 500 by 2. So if we will perform a matrix multiplication here, so the output of this multiplication is going to be 3 by 2, which is our desired result. Okay, so this is how we are going to perform this. Now this is done. So let's move on to our hidden layers. Okay, Yeah, let's move on to our hidden layers. So for the hidden layers, what we have to do is DTWL. Okay, so again AL minus 1, and in this case this is nothing but W from the next layer L plus 1, and delta from the next layer L plus 1, which is going to be normally multiplied with activation value of the same layer. So I have already explained all of these parts, like what are these and how we came to this solution. So if you want to understand them completely, then please watch my previous parts in my MLP series. So let's suppose this is the L layer, this is L plus 1, and this is L minus 1. Okay, so let's take care of this part first. Okay, so what we have is, in this case, let's first talk about this part. So this is going to be again the Z value of the L layer. We have three, we are going to have three Z values, and we have 500 examples. So the shape of it, the shape is going to be 500 by 3. Okay, now we have to perform dot product on these parts. Okay, this is a normal multiplication, but this is going to be a dot product. So let's suppose what we have W for the next layer. So the W for the next layer, which is this, is going to be this. So this is going to be 3 times 2. Okay, and then we have delta for the next layer, the delta for this layer, and that delta was 500 times 2. So now what we can do is we can take a transpose of this. So this is going to be 500 by 2 times dot multiplied with 2 times 3. So the output of this is going to be 500 by 3. Now if we will normally multiply this 503 by this 503, then our output is going to be of the shape 500 by 3. Okay, so this is the shape of this part here, 500 by 3. Now let's multiply it with this part. Okay, so if we will multiply it with this part, which is the activation values of this part, and this is going to be nothing but this is going to be 500 times 2. Okay, now if we want to multiply them, what we can do is we can yeah, so if we want to multiply them together, 500 times 2 and 500 times 3, what we can do is we can take a transpose on this. So it will be 3 times 500, or no, we cannot do this, sorry. So is I made a mistake. It is not multiplied like this, but what like the last formula that we derived in this, this was the case. Okay, so the last formula that we derived, but now we cannot just take it like this. So the original formula was delta L and this. So now if we will take a look at this part, 500 by 3 into 500 by 2. So now we are going to take a transpose of this, and this transpose is going to be resulting in 2 by 500 dot product with 500 by 3. So our output is going to be 2 by 3, and which is going to be the shape of this W. So our output is correct. Okay, now this is how we are going to represent our data when it is going to be of the form 500. Basically when we have multiple examples, or we want to use batch gradient descent. So this is how we are gonna use our what do you say, so this is how we are gonna use our representation, and this is how we are going to make our matrices in the case of multiple examples. So you might be wondering why I switched their positions. So if you watch my previous videos, in the video I was driving this formula. So when I was doing this, what we had is we had the chain rule. Okay, so which was d, that was upon the z, then that z was upon the activation value. Okay, then that activation value was upon again z of the previous layer, then that z was dependent upon the weight matrix. Okay, so this was this part, and this was this part. So this is the original form, but and for this, this is what I have done. Now if you want to explain this completely, then please go, if you want to understand this completely, then please go and watch my old previous videos. Otherwise you cannot understand it so easily. You have to like write it down each and everything in detail. And I know that it is a little bit hard for me to explain because I'm using a mouse here to draw everything, to write everything, which is very difficult for me, believe me guys. So I hope that you understood it. Please, if you have any doubt, you can ask me in the comments. And it is very easy. The thing is that you just have to be very careful when you are understanding it for the first time, because if you even forget a single thing, then you won't be able to understand the complete thing. Now, so I suggest you go and watch my all the videos in this series, and also you also have to have a grasp on what do we say, uh, back gradient descent. So in that gradient, in gradient descent, I have already explained what a gradient descent is, how it is, how it does it work, or why does it work. I have explained everything in my linear regression series, so you should go and check that video also. You should go and check those videos also. So guys, thanks for watching, and I'll see you next time.